a review of what we have already done about inverse functions, right? Just a little bit review. What is a function? I introduce a function as an instruction, not formula. I give you an input value, you follow an instruction, and there's an output value. That's how you should view a function in higher mathematics, right? Not just one formula. All right, so here's an instruction. I give you a real number. You consider that real number as x coordinate on the unit circle. And once you find that point in x coordinate unit circle, read the angle t radian. That's the instruction, right? Make sense? Something doesn't make sense. What if I give you real number 2? Then you try to find 2 in the unit circle, right? X coordinate 2? That makes no sense, right? Why? Because on the unit circle, there's no x coordinate 2. It's all in between 1 and -1, right? So that doesn't make sense. But if the given input is between 1 and -1, then there is a point, right, on the unit circle with that x coordinate given. And then I can read off the t angle. But there is a still problem. What is a still problem? I give you 0.72. The next thing is that you have to find the point on the unit circle with that x coordinate. Then what is the problem? How many points are there? 2 points. Then you're reading of the angle, and which one are you talking about? That's a question you have to ask, right? So we have to choose that angle, but if you choose that angle, then it finalizes the instruction. I give you a real number, and you follow this instruction, and you get that angle. That is called inverse of what function? Cosine. X coordinate angle, that's a cosine. So cosine is like, I give you an angle, you read the x coordinate. It's opposite. I give you an x coordinate, and you read the angle. That is called inverse of cosine, right? How about this one here? I give you y coordinate. It's inverse of sine. How about I give you slope, and then you read the angle. That's inverse of tangent. That's summarized here. So that is the very mathematical definition of a cosine inverse, sine inverse, and so on. It's not given by a formula, right? It is something you can do it in your head, and there is precise value we cannot compute. So we use a calculator. And they're written like this, and I'm using the input value letter x and y and m for you to remember this thing, but quickly they change to x and x and x. The dummy input variable x. You should be able to interpret it correctly now. How about these t values? I give you an x coordinate. There are 2 angles. Which one do we choose? We did that in our triangle problem. Cosine, for the answer is this one: either first quadrant and second quadrant, or first quadrant and a fourth quadrant. How about cosine? Anybody remember about cosine? Which angle the calculator tell you? First one and the second one, or first quadrant or a fourth quadrant? First quadrant and second quadrant. That was a cosine, right? Okay, triangle problem. And the other 2, always the first and the fourth quadrant. The other 2 is repeating this value, so they choose this one to take care of that. All right, here is the summary of what we have just discussed. Cosine inverse, we plug in the x coordinates, but you can't exceed these numbers, -1 and +1, right? And this is the part A. Writing this one down is a part A of quiz. There's part B is sketching. This is the part A. So you're supposed to write this one down. So -1 and +1 make sense? These are the allowed x coordinates. You can put it in there. But what kind of angle you get out of it? 0 to 180 degree, but now we're in the real number t or radian function, so it should be 0 to pi. Does that make sense? Yeah. And sine, the same thing, same number allowed, but it chooses first and the fourth quadrant, so radian angle measure must be -π/2 pi, +π/2, right? Do you understand why the tangent inverse allows everything? Slope is not about the coordinates. Slope can be, arbitrarily large. 2015 slope. Think about that. That's always possible. How about this range part? Why is this parenthesis not closed? That's right. It is not defined vertical. That's right. Okay. So, make sense? So you have to quickly reproduce this one. So I think the statement goes like this. State the domains and ranges of cosine inverse and sine inverse and tangent inverse, right? And you do this sixth thing. Understood? All right, next thing is sketching the inverse function. So here's a quick review on the inverse. If you don't understand this thing thoroughly, go back to chapter 3 and they discuss this inverses thing. But basically is this: graph of a function is input value goes to x coordinate there, output value goes to y coordinate. That's the meaning of the graph of a function, right? So a comma b means a is your input in here for this function, b is output, whatever the instruction you got out of it. But inverse function switches the input and output relation. We just said x to t and t to x, right? So if a comma b is a function in here, points for the function, b comma a, if you swap that input and output, that must be the part of the inverse function. Don't you think? Right? Input becomes output. So that must be it. So what is the relationship between these two? If I have 1 comma 2, where is 2 comma 1? Right? Then you can sketch it. The answer is this reflection. Across what line? The universal line, the 45-degree line. So if I have 1 comma 2, reflect that mirror image across the y equals x, that's 2 comma 1. Very nice description. So that's what you're going to do to the graph of this one. To reflect it, flip it across y equals x. So here's how you're going to do it with those 3 functions. Let me first save this one. All right, we're back. Nope. Yeah. Right. So here's a sine graph. Little more detail is introduced here, sine graph, which is facts from calculus. So what is this line? Y equals x, thank you. Why am I sketching that? Y equals x? Because it's supposed to be reflection across that. So how is the sine x compared to that one? That exact comparison is very subtle, and that is justified in calculus. So when I sketch sine x, I claim that at the beginning here, it remains like a straight line, right? That straight line is actually this y equals x, and that's the subtle part. So you make it almost like a y equals x, but the fact is that it's a little below. We remain below like this, going up to here like that. So that's right before it's bent down again. What's the coordinate here? Pi over 2. Thank you. Pi over 2. It's about to bend down. What happened the other side is staying above like that. And what is the coordinate here? Negative pi over 2. So what about the y coordinate here? 1. Negative 1. Is the graph of what function? Sine x, not sine inverse, right? This is sine x. And even continues, but I truncated pi over 2, negative pi over 2. So that it doesn't repeat again. This is the range of inverse function. Okay? So if you look at this box, it's kind of longer and horizontally, right? If you flip it, it becomes taller horizontally. So keep that in mind to make it nice picture. So we're looking at this box, and but first draw that line y equals x. Good. And what do we do to that graph? We reflect it. Think about this portion in here. You stay below y equals x. If you flip it, don't you think this is going to stay above y equals x as you flip it? Across it here? Mirror image? So you stay here and stay a lot like that y equals x, but always stay above this time. It's flipped. And then you naturally make this horizontal vertical part a little longer because of the bend. How about this portion in here? That stays above here, right? As you flip it, now it stays below. So here, go down in the same amount, go down like that. That is the graph of y equals sine inverse x. There's just a couple more things that you have to write it down. Almost. So let's look at the coordinate here. Who can guess what the coordinate of that one is? The top one here. Pi over 2. Where does that come from? It was originally here. It's flipped across, becomes a vertical line. Does that make sense? How about this guy here? This is right. This is a 1, and that's this one here is negative pi over 2, and the other one here, negative 1. This is it. This is what I should write down. Very first answer to part B of the quiz. Fair enough? All right. If you remember this reflection and this subtle shape of sine x compared to y equals x, maybe you can reproduce it easily. Yes? No, just this one, just in the box. All right. The cosine, I'm not trying to reflect it because it's very confusing. So I'll just sketch it and hope you believe it by looking at this point and where the point is going. So cosine 0 to pi, remember that different choice? So here's cosine. Start from top, and here what is this is half of it, and this is a pi. Half of it is pi over 2. Bend down and passes. Straight line. There. And actually the slope around the straight line shape is actually slope negative 1. Okay? So that's the portion of a cosine graph, like that. And this is 1 and negative 1. And this is also horizontally long box. As you flip it, it's become a vertically taller box, right? So let's do that in here. Actually, it turns out there's no portion under as you flip it, the x-axis. So I'm going to put it like that. So think about this point. Where this point goes? This point is 0, 1, right? As you flip it, do you know where it goes? 1, 0. Let's see how it is. Here's 1, 0. Now, second point in here, where does this point go? This is like pi over 2, 0, right? Correct? Where does that go? 0, pi over 2, right? So that goes here, 0, pi over 2. Y coordinate 0, pi over 2. How about the last point here? That's x coordinate. What is x coordinate here? Pi. What is y coordinate? -1. So where is this one going as you flip it? -1, pi, the 2 times there. That's where it's going. So that's the box. All right? You should begin in here, arrive there. Final moment of your pen stroke. Here, it's concave up. That's one way to remember. Concave up. You stay on that line a little bit and bend it down. Look good? And to enter the final one, you have to follow the guideline at the end, the dotted line there. So that's the cosine graph. Y equals cosine inverse of x. Make sense? So here is the thing. Everything is inside this bounded curve. That's all you have to write down. But don't miss that number. You can simplify the number here, just 1, pi over 2, and pi. Those numbers should be there. Any question about cosine inverse? Sine. So here's the graph. Much better shape here. Sine inverse x. Flipped across y equals x, staying above the first quadrant, above y equals x. Here is the cosine graph. Starting from 1, 0, going across like that. Fair enough? All right. What is the last one? Tangent. So let's start from tangent. Tangent's really tall, right? Because its range is negative infinity to positive infinity. What are these two lines? X equals pi over 2. The other one? Negative pi over 2. Also said that when I sketch tangent x, that it begins like a line at the beginning. That line is also y equals x. That's a fact from calculus. there, stays like y equals x, and then lift it up and go to infinity, right? So, go to infinity. The other part stay like in that line, but stay below, go like that. That's y equals tangent x in between that central strip. All right? And only that part, because it's one-to-one, only that part, and that's the cut we choose for inverse. So let's see. You see this infinite vertical strip becomes horizontal strip, I think, because of the reflection. So here's y, and there's this line, and there's that line. So what is the coordinate of this line? Y equals what? Pi over 2. Yeah. The other one? Negative pi over 2. And what line are we going to sketch here? Y equals x, the reflection line. Think about part that stayed above and below. This one in here, in the first quadrant, stayed above that line, and what happens now? Stayed below the line because of that reflection. Fair enough? And this one, it stayed below and stayed up. That curve. This thing is called y equals tangent inverse x. Alright? Turns out this tangent inverse x is so important in calculus. And all the problems in relationship with rate of change and the quantity, that relationship, when you try to solve that puzzle, out of nowhere, the solution begin to involve this tangent inverse x. There's no trigonometry whatsoever, but answer begin to involve this one. It's very, very important. Surprisingly important function, turns out. That's why I'm doing this, actually.